In this video, I'm going to be going over Module 13.2, Exponential Decay Functions, and we are going to use an online graphing calculator, Desmos, to show us what this looks like and what this looks like. So right now into Desmos, I have punched in 1/2 to the power of x, and this is what it shows me. So if I zoom in, well, first if I look at it from far away, you can see that it's dropping quite rapidly, and if I zoom in, let's look at some key points we have. So right here, we have a point 0, 1. Right here we have a point 1 and 1/2, and it's rapidly decreasing, but if you notice, it never crosses 0. So let's see what 1 divided by 10 to the power of x looks like. Okay. So now if I'm looking at 1 divided by 10 to the power of x, notice I still have the point 0, 1 right here, and then I should have the point 1 and 1/10 right there. So it's decreasing much rapidly. Okay, so now that we've seen what the two graphs are going to look like, we are going to go to page 652, and we're going to go over explain 1. So it says when graphing transformations of f of x equals b to the x, where b is between 0 and 1, meaning that it's a fraction less than 1, it is helpful to consider the effect of the transformation on the two reference points. So here are two reference points, as well as the effect on the asymptote y equals 0. So the table shows the reference points and the asymptote for f of x equals b to the x, and the corresponding points for the asymptote transformed by this here. So I'm going to flip the page and look at the chart that they're talking about. So here's the chart, and here is that transformational form that they're talking about here. So what happens is our reference point, our first point, if it was just b to the x, would be 0, 1. But when we are talking about a function that has translations here, see how it has the a is 3, then it has a x minus h is the exponent, and then a -2 here. What are those shifts going to do? So it's going to take the point 0, 1, and it's going to shift it to be h, comma a plus k. And then our second reference point, if it was just b to the x, it would be -1, comma 1 over b. And what it's going to do when you have a transformation is it's going to shift it to be this. And then our asymptote, just like it was for exponential growth, it's just y equals k. So let's see if we can identify these and apply these transformations. So if I compare g of x equals a times b to the x minus h plus k, I get that a is 3. I get b, which is this right here, is 1/2. H, see it's x minus 2, so h itself is positive 2 because it'd be x minus 2. And then k, remember you keep your sign, and so that -2 is my k there. So let's use these transformational points here, plug them in, and find my points. So I take h and I plug it in and I get 2. I plug in a, which is 3, and I plug in k, which is -2. And so if I simplify this, I get 2, comma 3 minus 2 is 1. So 2, comma 1 is going to be one of my points. For my second point, I have h minus 1. So h we said was 2. So plug in 2 here. 2 minus 1 is how I get 1 here. And then for a over b, so a was 3 and b was 1/2. 3 over 1/2, remember, is the same thing as 3 over 1 times 2 over 1. And that's why we get 6 here So if this equals 6, what's 6 minus 2? That's 4. So this is my second point we're going to graph. And then the last one is your asymptote here. And my asymptote is just whatever k equals, so it's y equals -2. So let's graph these points. 2, 1. 2, 1 is my new point. 1, 4 is my new point. And then my asymptote is at -2. So if I sketch this, I should have it decreasing rapidly since this is a decay function. And it should go through those points. Approach my asymptote but not cross it. So now let's try it for part B. So let's identify g of x equals a times b to the x minus h plus k. Let's identify my variables. So a is the number in front, so that looks like a -1. B is 1/10 the number here that's being raised to the exponent. H is what's being subtracted here. So remember, we switch our sign for the h, and so this is a -2. And for k, we keep the sign. So I have a +8. That makes k 8. Now, find your reference points. So you're going to have to memorize these two formulas if you're going to use these reference points instead of a t-chart. So it's h, comma, a plus k. A plus k. And let's substitute these values in. So h is -2, a is -1, and k was 8. So I have -2, comma, -1 plus 8 is 7. So there's your first point. Your second point is h minus 1, and h was -2. So -2 minus 1 is -3. A is -1, and B in this case is 1/10. So I substitute that in, and then I have +8. So -1 over 1 times 10 over 1 is how I would simplify this, and then I have to add 8. So -10 plus 8 is how I get -2. So these are the 2 points that I'm going to graph. -2, comma 7, -3, comma -2. So let's turn the page and graph them. So the points that we are graphing were -2, comma 7, and -3, comma -2. So I go -2, let's see, 1, 2, 3, 4, 5, 6, 7, -2, 7, and then -3, -2, 1, 2. So my asymptote, I need to draw that in order to understand where this graph goes. And so since k in my function was 8, I'm going to get that my asymptote is y equals 8. So that means I have my asymptote here. So I know that it's going to approach my asymptote but not cross it, and then shoot all the way down to that point there. So this is what my translated function looks like. So there are 2 examples. One example for your turn 3. Go ahead and see if you can identify what H, K, and B are, and see if you can find your translated points.